Okay, this video I picked the topic, two memory issues for homework assignment number 6. This is because when I interact with many students from this class on homework assignment number 6, I realized that there are two important memory issues which is causing a lot of runtime errors such as segmentation fault, which we dig down the code and then so many of them come back to exactly the same thing, which is this two memory issue. So I think that's a great stuff that we found out by working in this homework. I think this is a instruction moment for me to specifically cover what need to be careful to handle the memory related, especially for C++ programmer. By the way, when I interact with students, I told them, hey, if you're a Python programmer, you probably don't need to worry about this. But in C programmer, we do need to handle this. Okay. All right, so this is what we like to do in homework assignment number 6. Basically, I explained in the previous lecture about how this function, especially that we talk about this two function. One is called JSON post merging. The other one is called JSON to post, which is for your HW6 search and HW6 update. You're going to use this two function from the client side and from the server side to basically put the logic together. And furthermore, at least in my reference implementation, we talk about the concept called reusing the code from this two, because when you work on your homework assignment number 5, you have two program. One is called HW5 produce, one is called HW5 merge. They're both independent program. They're sharing a lot of logic together. So in homework number 6, what we actually do two things. Number one, we try to make those two independent program become a separate program that we can call them as a function in multiple locations, because we call, for example, JSON to post in both server and the client program. So we kind of reuse those program module. That's the first thing. But the second thing is that we actually found this called JSON post common, that we can use this same code for both the merging and the post, both search as well as updating variety of situation, which is actually very nice from the software reusability situation. Okay, so we have done that. I show you reference implementation, how this can be done. Okay, but there was one thing I realized, that there was a difference between your homework 5 and homework 6. Is that in homework 5, that the logic that you have implemented is actually put into one separate program, is under the main function. But in homework 6, what we have is a separate file, and they share this code, and this is embedded in a different function called, for example, we have 3 functions listed in this slide: JSON post common, JSON post merging, and JSON to post. When you have function, means that you have to handle the memory related to the function, and also the function will be called, will be returned, so you get out of the scope of the function, and where are those variable and memory you allocate. Okay, this would not be a problem for homework 5, because number 1 is a separate program, number 2 is actually all on the main. What some of you might know that the difference, now I'm going to go to the first issue about stack versus heap. This is the first issue. So typically, we allocate, there are two elements of your program related to the data and the memory are actually put down on the stack. That's what we call the local variable, that everything you declare within the scope, you declare that as a local variable, is on your stack. And the second thing is the argument to your function, the things that's input to this function those are also on the stack. So your stack has argument and has a local variable. The thing is that you have to notice the difference between stack and heap is that, by the way, for heap, anything you use malloc and free or new and delete, those are things are on the heap. And the critical difference between the stack and the heap is that if the memory is on the stack, when you exit the function, the memory is go back to the runtime environment, and such that if this program is calling another function, and that particular piece of memory is reclaimed and reused for different function. So you can imagine if you call a function, you use some local variable, you create very nice post memory or JSON memory. When that function exits and the program call another function, then suddenly the memory is all gone. But you might still keep some pointer somewhere in another part of your program. You try to access that memory. And I'm sorry, because that memory has been reused, it's totally corrupted. And when you try to refer to that memory, you got a segmentation fault. Okay, so that's why at least some of you, in fact, many of you actually got this problem through yesterday, even today, that I talk about some of the students that you had this issue. So I'm going to just tell you that how to know the root cause of those problems and try to see how you can write a program to avoid those problems. Okay, so just very quick, I actually show this slide. This slide you will see a lot more when you get to ECS 150 in operating system design. But you can see that this is your memory layout. I mean, C programmer or C++ programmer, that they got exposed because of the address and pointer, they exposed to this memory layout. And you can see in the middle, you see that there is a stack. And then in a little bit go down there is a heap there. So that's actually two regions of memory in your memory address that's actually handled very differently, depending on your local variable or argument versus you use new and the malloc. So the thing is that if you can use new and malloc, of course you have to figure out how to free and delete, but you know the memory will be there regardless you enter and exit a function. Okay. All right. So let's take a look at this in the context of your homework 5 and homework 6. So in homework 5, you're using main, and everything is under that main function. And remember, the main is the first function and the entry function that you're going to call for a program. And therefore, this main function is on the bottom of the stack. So it means that it will not be replaced. When it got returned, it means it exits the program. Okay, so in fact, main function, everything got declared inside the main is pretty much also being held there, because when it's done, it's done. So therefore, if you put everything in the main, just like your homework 5, you don't have a lot of issue about what we talk about, the stack versus heap, because even it's on the stack, it's pretty persistent there on the stack. However, we change to homework 6, we actually move the code into different function, like those 3 functions we talked about earlier. If you use still the same style, that you're going to get into trouble. Okay, so let me actually now compare the code between the HW5, what code that we put in the main, versus in homework 6 in my reference implementation. I think I send a JSON post underscore redacted. And if you compare those two pieces of code, which is shown here as well as shown in the redacted code, and you can see that they're almost the same in terms of the logic, but there is some difference in terms of the memory allocation. To avoid this problem, I like to point out. Okay, so this piece of code is the section that I provide in the reference implementation for reaction. Okay, this code I actually covered long time ago in one of the lecture. Okay, by the way, at that time when I wrote this code, I didn't thought about that issue. So in some sense, I made the original mistake when I write the code. I didn't write it in a way that's actually more protected in terms of memory, because at that time I'm also doing hacking and I'm also just getting things to work, and it works fine if I put it under the main. Okay. So this function is exactly like this. So now let's actually compare a little bit about homework 6. And now you see the code is a little bit longer. Code is a little bit longer. It's organized a little bit different. But there are still some similar code that you can see. Even the property name, everything is the same. But I just adding a few things. So if you compare this to, now let's look at this slide. I actually already block all the code, they're the same. Okay, so the yellow square is just cover all the code, they're identical to the version of the code in homework assignment number 5. So let me actually explain to you a little bit about the difference. The first difference is that now I'm actually more careful. I actually check whether from the JSON value, whether that reaction is even there, whether you have a reaction. So I think that is just a defensive call. In fact, the first difference, I'm not 100% sure if I remove that, I will have any problem, but it's okay. I mean, I just add one more check. If this reaction is null, if it's null, then I don't do the rest of the thing. Okay, that's pretty much it is. Okay, then I want to talk about the middle part. The middle part, I'm actually protecting my code. I check before I actually create those objects. In this case, before I even create reaction object, I insert a check to see if you do have avatar name, you do have a VSID, you do have created time, you do have type. Those 4 I must have in the JSON, in the post JSON for me to do the processing. In my previous code, you can see that I didn't check that. I didn't check that. It works because the test program has it. The test JSON has all this, so it won't break if I don't have that. But I start developing this when I handle tags, because when you handle tags, sometimes you have this, sometimes you have that. So I actually, when I develop homework 6 sample program, the solution, I actually reinforce my code by checking everything that I believe a JSON, a post JSON should have. If you don't have that, I won't even bother to enter that. Okay, so that takes care of those 2 pieces of code. Now the important thing, the memory issue, is actually the other 2 pieces, which I highlighted here. Okay, I highlighted here. So you can see on this slide, now the way I do it is that I first check whether this post, the pointer to the reaction, whether that's null or not. Whether this reaction has been initialized before. Okay, so I add that line, very simple. I want to be able to reuse for merge and for update. For merge and for the produce or update, whatever you want to. So if this is a first time I actually want to process reaction, and on the post it doesn't have any reaction before, then which means that the reaction vector is never created, then I will call a new vector reaction star, which at the moment I initialize the pointer of reactions under the object my post, pointing by my post PTR or my post, either way. So here is the check for me to whether I should first time initialize. So in other words, if you don't have any reaction, I would never invoke this piece of code. But the other thing is important. Here I'm using new. Because I'm using new, that this memory of the reaction vector is actually on the heap. So which means that when I exit this function, that this vector will still be there. Okay, this vector will still be there even I exit the function for JSON post common or JSON to post or JSON merging. It will be there for me to do dump J, to me to do other thing. Okay. And then at the end, you see that now I'm doing pushback. When I create in the middle of the code, I'm essentially decide whether I should create that reaction pointer. And after I done the reaction pointer, I immediately push back into that vector I just created. Okay, so now I want to tell you two things related to memory. Number one, I create a reaction vector on the heap. And then I push the new creation reaction object I just created, I constructed, and push into that vector. So that vector reaction pointer, by the way, inside the yellow box, the reaction is also using new to create. So which means if you see new, they're on the heap. So everything is on the heap. So later when you dump J, it will be still there. Okay, so that's the things if you look at this correspondence between this code. Okay, all right. So now let's go back to look at number 5. So I also use yellow box to block all the codes is repeated, and this is the code that's actually remaining in the homework assignment number 5. Okay, so if you look at this, I only have 3 lines of code. The most important is the first line. The first line is a place where I create the reaction vector. So I actually call it vec underscore reaction, which is a vector of reaction pointer, and I highlighted there is on the stack. Because why? This is a local variable. You didn't see new, you didn't see malloc. This is a local variable, and it's on the local variable. If it's a main, it's fine because it will never be pop out from the stack. So it will be there, and no problem. And what we did in the next line, you can see that now when I push back to that pointer, I'm actually push back that reaction pointer within that yellow box, which is created by new, by the way. And I'm actually pushed back to this vector data structure on the stack. Okay, because the first line is on the stack, so now the second line in this block is on the stack. And guess what? The third line is now I'm actually, instead of initializing the reactions pointer, I actually just put the address of that vec reaction to my post.reaction. So by the way, here's the issue, is that n sign before of the vec underscore reaction, that address is also on the stack because it's on the stack. It's memory. Everything is on the stack. So you essentially put the pointer address to somewhere in the stack and into the my post.reactions. Okay, so this will cause problem when you move this code out of the main function. Why is that? Because now you move to this piece of code into a JSON post common. Now it's in a different function. When that function exits, immediately that piece of memory, which is including this vec underscore reaction, might be reused by somebody else. When it's reused by somebody else, when you use the dump J on the post, try to print out about the reaction information, you're actually pointing to something else, which is not expected to be a reaction vector, and therefore you got all sorts of problem because of that. Okay, so so you can actually, in fact, this is a great experiment you can do, just like what you do homework assignment number 4. You can actually print the address about vec reactions or the pointer got created by new, and then just try to compare whether the address region, because I told you that the stack memory address will be very different from the heap memory address. And that also helps to confirm, give you a better sense about the memory address. Okay? All right. Okay, so this is the first memory issue I want to talk about. Is really, I think we make mistake, even including me, but this mistake is a learning moment for us to, as a C++ or C programmer, we know really if we don't know the stack and heap, the difference or how to allocate memory, it's going to kill us. Okay, if it's going to kill us, means it's going to kill any kind of system you will be building when you in the future when you get your job, which is important because the airplane might crash because of this. Okay, all right. So, but that is not just the only issue. There is another issue I would like to point out with you, which is even, I think it's very interesting. It's actually related to the same problem. So I realized this problem when I helped one particular student debug her code. And I realized there was another problem. This problem is tricky because this bug will not always show up in certain environment. So it's related to the constructor and the member initialization. So for example, the post object has a variable called, let me just bring up the slide. For example, post. This object has one variable called reactions, which we talk about. We use new to initialize that reaction. But my question is that when you call the constructor, if you didn't set the value of this point to the reaction, what will be the value of this to the reaction? By the way, this point to the reaction, that one is a pointer to a vector. If you see our definition, that is a pointer to a vector. But a pointer is address. Then we want to see what is the value of that address that you initialize when you decide to create an object like a post. Okay, by the way, if you check the constructor of the post, at least the code I gave out, it doesn't initialize the memory. It just initialize a few variable, but it never initialize a reaction. Okay. So it's interesting is that if you look at the code, why this is important? Because if you look at the code I just showed you earlier, that before I create this new vector reaction star, this pointer that put it initialize the reaction, I did check say my post pointer to the reaction is equal to null. So that line of the code there, it implies my belief is that if this is never being initialized, then I'm going to do new. But it also implies, I assume if it's never being initialized, then it should be null. The value should be null. So in other words, I'm answering my question. I asked you, what is the value of this creations, this reactions, and I assume the pointer value is null. So it means that I can use that, rely on that value to check whether the reaction pointers ever being initialized. Then I'm going to call the second line to new it. And that is the logic. And now here's a surprise. That this logic will work for MacBook, for OS X. It might work for CSIF, but it doesn't work for other environment. Like yesterday, I was helping a student working on, she was using Windows 10. On top of that is WSL, the Windows subsystem for Linux. And under there, the C++ environment doesn't initialize all your pointer to null. So which means that it will only do the memory that you have, that you assign in the constructor. Everything else, you didn't do anything else, then the memory is just basically random value. Whatever memory you're using, that memory value it has. So I remember the other student asked me why I use the code B0 from time to time. And my answer to that, the reason you can see my code, I use B0 because B0 is null. So I use B0 to nullify all the memory that in my object, so it will clear this problem. That's why I use B0 to clear everything. Okay, there is an issue with B0, is that if you have an object in C++ object that has any perspective of virtual function, you cannot use B0. B0, if you think about homework 4, you have virtual inheritance and multiple inheritance. In multiple inheritance, you see that everything is a value, data value. You can use B0 to clear all of them, the size of object, whatever, work study, and you reset everything to B0. That's perfectly okay. But you cannot do that for virtual inheritance. Because virtual inheritance, you have a two-pointer virtual table that's provided by the runtime environment because it needs to point out to virtual. And therefore, if you do B0, you lost that information. That those two are immediately get cleared out, then your object won't work. So B0 is reset everything to B0. It can only use if the object doesn't have any virtual table pointer, which posts, you cannot do that because posts have a virtual function. And anytime you have a virtual function, you have a virtual base, you have those kind of virtual, you're going to have a virtual pointer somewhere in your initialization. So you have to go through each variable to initialize to be null. And in order to make sure your program, like this line of code, it will take care of that. Okay, so this is I would say it's a very, very good lesson for both me and all of you to learn about how to handle the memory in the real world, because you have to deal with different environment and different concept. Is a heap versus stack or virtual, non-virtual? How do you reset the memory, and how do you make sure the memory is still there when you exit the function? Okay, and that's something which I think is important. You should learn, because this is not only valuable for you to handle homework 6, but later. Later means 150 or other courses or other real project you're going to contribute your time into for our society, that make sure that you have this concept clear. Okay, all right, I will talk to you later.